you ready?
I'm so ready.
All right, you got a seagull on top of the lighthouse looking at a fish. So here we go. We know you got to draw your own picture. So here's the lighthouse. Here's the seagull. Here's the fish. The goal is 78 feet above sea level. The goal is 320 feet from the fish. So somewhere in that picture, I have, girls. Somewhere in that picture, I have to put a 320. The goal is 320 feet from the fish. So where's the 320 go? Hypotenuse. There's the goal, there's the fish. Find the angle of depression. Now, I just marked the angle of elevation, but remember they're the same thing, and our angle always goes right there. All right, whether it says depression or elevation, doesn't matter. That's where it goes. Now, write an equation. So you're going to look at this angle, you're going to look at these two sides, and then you're going to decide, is this going to be a sine, a cosine, or a tangent? It's going to be a sine. How do we know it's going to be a sine?
Opposite over hypotenuse.
Sine equals opposite over hypotenuse. Now, how do I type that in on my calculator? This is the tricky one. This is where you go straight to inverse sine. All right? One more time. When do I use that button on my calculator? Whenever x is the angle. When x is the angle, that's the button I have to use. I don't multiply by 320. I don't do any of that stuff. None of that stuff will work. You have to second sine 78 over 320. So the answer is 14.11 degrees. So your angle is 14.11 degrees. Okay? Now I have an airplane coming into the airport. The airplane is currently 6,543 feet above the ground. The angle of depression is 23 degrees. And the question is, how far is the airplane from the airport? So that's going to be x. Where am I going to put x? Hypotenuse. There's a plane, there's the port. How far apart are they? Right there. So take a look at it. Is it a sine, cosine, or tangent? It's going to be sine again because we have opposite and hypotenuse. So sine 23 equals 6,543 over x. Now the last problem I did was a sine, and I used that button. Am I going to use that button on this problem? No, because the only time I use that button is when x is the angle. So this one, I multiply by x and divide. And type in. I got 16,745.53 feet. Anybody else get that? Don't just watch me, you need to be typing in yourselves. Now we have another flagpole. So we have a flagpole. makes, it says find the height of the flagpole. It makes a shadow 31 feet long. Where do I put the 31? Where's the shadow? On the ground. Shadows are on the ground. And the angle is 29. Well, we've had a couple of sign problems in a row. Is this gonna be another sign problem?
No.
Nope. What's this one gonna be?
Tangent.
Tangent, opposite over adjacent. So tan 29, remember when you write these equations, the angle always goes with the tangent or sine or whatever it is. Okay? Sammy, sit up, honey. Are you sick? Okay. So x over 31. Am I going to use my second tangent button? No. I only use that button when that is x. So I'm going to multiply by 31 and type it in. So 31 tan 29, 17.18. How tall is the flagpole? 17.18 feet. One more. I got a building over here. I got a man looking up at the top of the building. So here's the man looking up at the top of the building. The building is 84 feet tall. And the man is standing 1,234 feet from the building. So where do I put the 1, 2, 3, 4 number?
Adjacent.
Yep, exactly, right here. Here's the man standing, here's the building. Now what would this be? Well, I know that's hypotenuse, but that would be if the question said, how far is the man from the top of the building? Or if there was a bird on top of the building, how far is the man from the bird? But we want to know how far is the man from the building. And what's the question? What is the angle? Okay, we know what we need to do because x is the angle. So first we write our equation. What is our equation going to be? Tan x equals opposite over adjacent. How does that go into my calculator? Don't do anything except type it in. What do you type in? Second tangent, inverse tangent, 84 over 1, 2, 3. Second tangent, 84 divided by 1, 2, 3, 4. So this is a tiny little angle, 3.89 degrees. All right, now we're going to put the calculators away. I mean, you can use them because you'll have your baby calculator, but we're not going to be typing in sines and cosines and stuff. We're going to do this page by hand, and we're changing into degrees. Number 1, practice test 2. How do we change into degrees? Luke? I'm not doing anything on my calculator. Stop. 7 times 180 divided by 10. So what is that? 7 times 18. Is that 126?
No, it's
126? So the answer is 126 degrees. You have to divide by 10 right now. All right, change 200 into radians. How do I do that? I know pi is 180, so I I need to figure out what's 200. So 180x equals 200 pi. So the answer is actually 200 over 180, but I need to reduce that. So I'll get rid of the zeros. And then a 2, 10 pi over 9. When you read question 3, do you envision this kind of a problem? I hope, because we're talking about finding the measure of the arc. That's what we're looking for. Before I used S, you can use whatever letter you want. That's what I'm looking for, is the length of the arc. I know my angle is 100 degrees, and I know my radius is 8 feet. What is my formula for arc length?
Radius.
Not the Pythagorean
Radius
theorem.
times
That isn't a right triangle.
Radius times radius.
Radius times radian. So arc length is radius times radians. Now, the good news is, that's only 2 things, and I already know one of them, right? Now, the problem is, I've got my angle, but the angle is in degrees, and it needs to be in radians. So I'm gonna do what I just did right here, only I'm gonna do it with 100 degrees. So I'm gonna do pi is to 180, as something is to 100. I'm gonna figure out what that is, and then that number is gonna go right here. So 180x equals 100 pi. So what is 100 over 180? 10 over 18, which is 5 over 9. Is that the answer? Is 5 pi over 9 the answer? No. 5 pi over 9 is the radian measure that now I can multiply by the radius and get my arc length. So multiply straight across. So that's 40 pi over 9. That doesn't reduce. The unit is feet. So the length of this arc right here is 40 pi over 9. That one you gotta be on your toes, because it is a two-stepper, 2 pieces to that problem. Okay. Now I gotta find all the stuff. And they tell me that the sine is 2/5. That automatically means what here? What else can I fill in if the sine is 2/5? Cosecant is 5x. So even if I'm clueless, I can do that. Now to find all the rest of them, I need what I always need, which is a picture. So I'm going to draw a triangle somewhere up here, one of my butterfly bow ties. You are told in the problem where to draw the triangle. What does it say about your angle? Where is theta? In between what? 90 and 180. So think about your setup. Doesn't that mean it's in quadrant 2? (90 to 180). And the sine opposite over hypotenuse is 2/5. What's the next step? Now I do the Pythagorean theorem, because what have I got right here? A right triangle. That's a Pythagorean theorem situation. That is not, because that's not a triangle. That uses this. Alright, so go ahead, use the Pythagorean theorem, tell me what you get for your adjacent side right here. Square root of 21, absolutely. Be careful, it actually would be negative square root of 21. Remember, if your triangle is drawn in a quadrant other than 1, something has to be negative. In this case, that's negative. Now, it's 21. Did anybody get 29? Don't admit it if you did. Because when you do the Pythagorean theorem, these are A and B. Right? And that's C. Don't admit it. Alright, now I'm ready to go. What's cosine? Negative root 21 over 5. What's tangent?
Yeah,
2 over negative root 21, or negative 2 root 21 over 21. Secant, 5 over negative root 21, so 5 root 21 over 21 negative. And then this one's gonna be negative root 21 over 2. Okay. Lots of points in that problem, but lots of ways to lose points if you're not careful. So keep a close eye on what's going on. Okay. Now we have this. Cotangent 300. Sine negative 420. Start there. So what's our strategy? How do we go about finding the cosine, or cotangent of 300 degrees? What's step 1? It's already in degrees. I draw it. I'm ready to draw it. So here we go. Where is 300 degrees? Right here? Isn't that 300? Butterfly bow tie. Use your head. I want that angle right there. It's formed by the 300 line and the 360 line. So how much is between my two fingers? 60. And 60 has a root 3 across from it. Anything negative? Root 3 is negative. Cotangent. What's cotangent? Adjacent over opposite. Wait a second. You're here. So who's missing over there?
Mackenzie.
Oh, I marked Macy absent. Sorry about that. You're confusing me. Nice. And alright. Better. Alright, so what's my answer? Adjacent over opposite. Did you get negative root 3 over 3? Alright, here we go. a little bit different. First of all, what does a negative angle mean?
Choose which way
It means I'm going this way, right? So these are my labels. Now wait a second. All the way around is only 360. That's 420. What's going on here? It's more than once around? So this would go all the way around. So here we go, all the way around. And then how much more? It's gonna go 60 more? Isn't it gonna go 60 more? But it's going negative, so it's gonna go 60 more like this. So there we go, that's negative 60. Because it's going in the negative direction, so all the way around is 360, and then 60 more gives me a total of 420. So here's my perpendicular. Shoot, I think it's that same triangle, isn't it? Because that's 60. Yeah, it's the same triangle. But it's not the same problem. Problem wants the sine. So the sine will be, yeah, negative root 3 over 2. Opposite over. You're a Latin person, Latin dancing person. There you go. Who do we have? Just one?
Three.
Three? You're gonna Latin dance? And nothing, it's just, you just sit here, you're half asleep, so I hope you don't drop your girl. Alright, inverse sine 1 over root 2. Now, that notation means I'm finding an angle. That answer is going to be some degrees. Okay, that answer will not be a fraction like this. This notation means you're looking for an angle. Now, where am I looking for that angle? Which quadrant? Positive number. Inverse sine, inverse cosine, inverse tangent. If that number's positive, it's in quadrant 1. Period. Quadrant 1. The sine opposite over hypotenuse is 1 over root 2. This angle is your answer. Can you tell how big it is? 45. So the answer to the problem is 45 degrees. This is going to be the same thing. You're going to be looking for an angle because it has that notation. Don't draw this in quadrant 1. That's a negative number. It doesn't belong in quadrant 1. Only positives belong there. So then you got to remember your rules. Which quadrant is the inverse cosine negative? What? 2. Julia says 2 and she's right. Sine and tangent negative are in 4. Cosine's in 2. Nothing. So negative 1 over 2, that is my adjacent over hypotenuse, that's my cosine. Can you tell how big this angle is? Well, this would be root 3, so won't that be 60? The answer is not 60 though, because doesn't my answer have to be somewhere between 90 and 180? And 60 is not. This is the answer to the question. So now we have to use our logic What is that? 120. So the answer to this question is 120 degrees. So I need you to look at the situation and make sure that 120 makes sense to you. 120 and 60 would make 180, right? So I knew that was 60. I'm trying to figure out what that has to be. It's 180 minus 60, 120. All right, now I got a couple more of the same section. Tangent, 7 pi over 4. Step 1. We haven't had to do it with these, but now we have to. We have to change 7 pi over 4 into degrees. Okay, so you do that and tell me what you get. Tangent 7 pi over 4 is the tangent of
315.
315. So now I'm getting ready to do what I always do. I'm gonna draw a picture. And it's 315, which is going to be down here. Bigger than 270, less than 360. There's my triangle.
$45.
45. Everybody see 45 there? Which then means 1 root 2. Then I stop a second. Gotta put some negatives in. Put a negative in. Right here. Those are easy to forget. Anytime you're not in quadrant 1, something's negative. I want tangent. Tangent will be negative 1 over 1 or negative 1. Hang in there, guys. I know you're all excited to go to the assembly. But you gotta get this going. Because I don't see you tomorrow, Monday. All right. Cosine 3 pi over 2. Step 1. Change it into degrees. So 3 180s divided by 2, that's going to be, what'd you say, 270?
Yes.
Uh-oh. What is special about 270? It's on the line. This is my angle right here. Straight down. That's my angle. What do I do?
Circle.
Draw a circle. I let the radius of the circle be 1. And then I'm going to find the coordinates of that point right there. So here's the origin. I'm coming straight down 1. So what is it?
Negative 1, 0. Or 0, negative 1.
0, negative 1. So x is 0 and y is negative 1. I want cosine. What's cosine? Don't say adjacent over hypotenuse, it's not going to work. X over r. When in doubt, look at your orange sheet. Cosine's x over r, so that will be 0 over 1, which is 0. All right, now comes the fun one. The really fun one. I need cosine to be negative, less than 0. Now, you guys, doesn't that automatically rule out quadrant 1?
Yes.
If anything's negative, you're not in quadrant 1, okay? And then I also need the cosecant to be positive. Alright, so pick a quadrant. 2. Let's look at quadrant 2. In quadrant 2, I would have a negative adjacent, a positive opposite, and of course, a positive hypotenuse. Would you agree with that? Is the cosine, which is adjacent over hypotenuse, is that going to be negative? Yes, good. The cosecant, which is hypotenuse over opposite, will that be positive? We got a winner. Right there it is. Right there it is. There's only one answer. There's only one quadrant that'll work in, and you got lucky. You guessed it right off the bat. If both parts fit, now, if it hadn't worked out, then I would pick a different quadrant and try it. The answer is quadrant 2. Alright, let's finish our sketches. In fact, maybe we can get all 3 of them up here and I'll hand back some papers while you are working on these. And then go ahead and come up and put them on the paper. So we have tangent, we have sine. And we have and we need period and amplitude. Do it. 36 hours. Do it. I'm gonna hand back some papers while you're working on that, and hopefully we'll have some volunteers to come up and do it on the board for us.
Yeah, she left last year. We sit in our grades for this, we sit in grades.
Yeah, I think so. I would imagine so, because everyone will go crazy. I really don't know, I think so. They didn't send me the season chart. Before ping pong, we had a drum off. Drums, people would come in and beat on drums. It was so loud.
Charlie would like that.
Charlie
I
would
would
love
love
that.
that. Charlie would win. We should bring that back.
And I'll wait till I retire, because my ears get ridiculous. It's so loud. Now, these guys made quick work of this. You should still be working, because I want you to do all 3 of them. And we'll check them and see how you did. All right, are we ready to look them over? All right, how does this look, everybody? Amplitude 1, period 120. What do you think? I think it's right, because you took the normal labels and divided them all by 3. That number's a divider. Beautifully done. Who did that one? Good job. All right. Pretend you're grading this paper. Is the shape right? First thing you look at, is the shape right? Yep, it sure is. That's a beautiful cosine. All right, goes up and down 5. Its amplitude is 5. That's good. Where did these numbers come from? These were divided by 4. Beautiful. Who did that one? Nice work. Starts and stops right where it's supposed to. It's perfect. All right, now we got this one. Is the shape right? It is a negative tangent. Is that right? Absolutely, that's right. That's a negative tangent. Now, these used to be negative 90 and 90, didn't they? But they got divided by a half, which is the same as timesing by 2. So we made negative 180, positive 180, and that made the period 360. I cannot find a flaw on the board. Perfect. Annie, Julie, you got a question?
On the second one, wouldn't the period be 90?
Oh, yeah, we switched around. Thank you, Julia. I didn't even pay attention to that. The period's 90, the amplitude's 5. Yeah, period is this way. Amplitude's up and down. Thank you, Julia. I didn't even notice. Okay? All right, what's next? Now we're going to get a couple of these done. We're going to convert to degrees, minutes, and seconds. So you remember how to do number 8 on your calculator. 287.175. And then second angle, DMS. And then we're going to write down exactly what the calculator says. So 287 degrees, 10 minutes, and 30 seconds. Nothing else, no commas or spaces or anything. That's just write down exactly what the calculator says. All right. Now, let's take a look at problem number 9. Now, when we did our test, we're going to have a problem that looks just like that. What is the very first thing you're going to do? When you get to problem 9, or what's 9 on here, what are you going to do? Well, you're going to type it in the calculator, but you're going to do something else first. You're going to make sure you're in the right mode. And so you can either go problem by problem, switching back and forth as needed. I prefer to go through and do all of one kind first. So whether that's degrees or radians, it doesn't matter. I circle or mark all of those, do that whole set first. Then I change my calculator and go back and do the rest. Does that make sense to you? You don't have to do it that way. But if you don't, you're going to be flip-flopping back and forth. Okay? So let's circle the degree problems right now, and then we're going to be out of time. So circle the degrees. Which ones are the degrees? B, D, and F. So the first thing we're going to do next time we're together is we're going to take our calculator out. We're going to be in degree mode.